Okay, so idea is multi-texturing. So before that, we will see kind of quickly a MIP mapping. So MIP mapping in the sense that now it would draw. If we see here, okay, so okay, so in MIP mapping we have to create so many sub images, and so what we need to do is, like, if this is the kind of the code, then we are at MIP map level 0. I need to create many images at MIP map level 1, 2, 3, 4, 5, whatsoever, and here in the image, so image would differ, means the next images that we have to pass. Okay, so first we'll see that what is the kind of requirement for the MIP mapping, why we need. So transformation I believe we are doing. So we'll kind of, we don't need transformation right now. And the textures are correct. So we'll run this. Okay, so nothing is coming. Okay, so Mr. Put alpha is 0. So this drama will keep, okay. We'll make 255, that is the maximum. And here GL, so we don't need now. So this story is over. Okay, so blending. Okay, we'll leave it decal, or we can say kind of replace. Okay, so this is the desired image, and now as we talked, this is the desired image, and if I open the program, there is a kind of a transformation is there. Transformation is kind of translate, rotate, and scale per shape. There are two shapes, global and image. Global is the global, image is the image. So if there are many images, transformation will be kind of per image based, and one is global. So what is global? Like if I say go right, okay, I have kind of in keyboard there is something like if I press A, it enables draw axis, and draw axis goes here. So this is a ready-made command which does the transformation and draw axis. Axis is 2 pixel wide. The width of the line is 2 pixel wide, and default is 0.5 length. For local we have set 1 length, so 2 is the width of the line and 1 is the length of the line. So that is the scenario. Now if I press A, so I think it should be visible. Now 2 axis it is drawing. So left side it is the global axis and this is the local axis. Okay. So if I press V, it shows what is the scenario. Okay, I'll press again. Okay, it is printing kind of some debuggable. So we'll disable this, that is better. Oh, that's what the problem was. Okay, so I'll try again, and I'll press tab and I'll say R, and I'll say S. So two axes are coming, and if I press V, so shape is the image, it is not global. If I press tab again, and shape comes to global. If I say global, then all the kind of transformation will happen on the global axis, not on the local axis. So I can say, now I can see the blue line, that is Z axis, X axis and Y axis, and I can rotate like this, the complete image. Okay. If I press tab and say V, I am at the image. Now it will be static, it won't rotate, and if I say Y, the local axis would rotate. That is also again in grand and local coordinate. So this is kind of a local coordinate. Okay. So this much is okay. Means I think this much explanation is okay. Okay, so I'll bring this again. Okay. So right now I am at image, and if I press far, it will go kind of in minus Z axis. Okay. I think someone should see the image carefully when I am pressing far. There is shimmering. It's kind of clear. I'll bring it near. There is shimmering. Okay. It's not smooth, it is coming in front. Okay. It's kind of, there is a something like glaring, something like shining. I mean, someone can see the kind of center of the flower, this region, this portion. So I am pushing it far. There is shimmering. It is more clear now. So this is unwanted effect. Means like, so if I okay, so this is what we don't want. Means how I can avoid this. So as per the theory, if something like this, then we need to create sub images, and we have to reduce the calculation amount that is too high. So for that, we'll go to the code, and in the code here, okay, so I'll say GL generate map GL texture 2D. Now if I generate map GL texture 2D, then automatically it is equivalent to if I have so many texture images and at different levels. So probably this is 1, 2, 3, 4. Okay, so 5 and 6. So instead of that, there is a ready-made command available, and just say generate GL generate map, and it would generate so many images, and it would bind in this texture map. That's it. Now the transformation should be better. That is the idea. Okay. Okay. So in map we have to set the filtering as map. So anything we can set. I'll say kind of to not go with high class computation. Map. Okay. So this is meaningful in the min filter. So map nearest. So it would select the map image that is the nearest, and then In that it would select the nearest pixel, nearest texel, nearest map. So among this, whatever comes to nearest, like if image size, polygon size is here, then whatever image it finds, map image find the near. Now inside the near map, again the nearest pixel. So no more calculation we are doing. Okay, so we'll try now the shimmering effect if it really goes away. So I'll press for no shimmering. I press near, no shimmering. Okay, whereas here what we saw, if I press for high amount of shimmering, okay, and here if I press for no shimmering, no high amount, there is no shimmering. Okay, if we see the center of the flower, there is no change at all. It is coming smoothly. Okay, I can try a bit more competition. Generate map and texture min filter nearest map, kind of linear, and this is also linear. Okay, now I'll press for again. No shimmering. It is completely flat. Nothing is there. Okay, it's a plain image. I mean, it's anyone can see this. There is nothing. Plain image is gone. This is the advantage of map mapping. The shimmering effect is gone. Okay, no glare. But in the first case, if I bring it near, heavy amount of shimmering. You can see the difference. See? It looks like it is computing, and that transition it is visible. Here if I bring near, nothing. Okay, so this is use of map mapping. Okay, so I think I can finish this story of map mapping. Now idea is we'll go for multi-texturing. So we'll revert back whatever we have done. So now we don't want those many high competition, and we'll say I am happy with the linear or nearest, so that it would be faster. Okay. Now in the multi-texturing, the images are two. Okay. So multi-texturing will take, I have a hut image. So this and this image, two images will do multi-texture. So that is multi-texturing. Okay, so I'll generate two now. Two, or I can comment this. so that I can uncomment later. So I can say text name 2, and texture it is generating is 2. In global section I can put one more guy called text name 2. Okay, here also, so that it can be propagated. Text name 2. Yes, Python is amazing. So simple to write the code. Okay, now we have text name and text name 2, and whatever we have done now, the same story we have to repeat. So probably I can shift this code here. Okay, and 3, 4, 5, 6, 7, 8, 9 to 9 line will young. Okay, I can close this and I can open. So the next diagram is kind of hut.png and convert to RGBA and whatever alpha we want to put. So we will use decal. So alpha we can make something like 50. So flower will be more and it would be less. Okay, and then texture name 2. That's it. So two images are there. One is text name and one is text name 2. Okay, same IMG we are using. I mean, image is being pushed inside it, so it should be okay. Now we'll go to display and we will do the magic of multi-texturing. Okay, so multi-texturing is kind of okay, so now we cannot run away. We have to specify the texture unit. So in which texture unit this image would be computed. The mathematics would be kind of computed in which texture unit. So we'll use texture unit 0 and texture unit 1 in computation. Okay, so when we see GL quad, before that we enable. So everything will happen in the context of multi-texture now. That era of blind is going away. So I have to say whatever I am doing in GL active texture, GL texture 0. Inside GL texture 0, we are enabling this, we are binding the texture and we are setting as replace. So first one is replace is, I think there is no problem. Okay, now we'll come to next. So I think we can just copy paste 4YY. Now GL active texture is 1 and it is 2. Okay, so bind texture to 2 and we'll do kind of decal. So decal is, as we see, decal, the mathematics that is used in decal is this. The alpha of the second one, the alpha of the second one, 1 minus and the previous one. So that is 50, we have said. So 255 minus 50. So previous one will be kind of a stronger, and the forward one we can say kind of back and forward, back and front. So back is strong because for front AS is low, and CS and AS CS and AS, or I can just copy paste this. So this is AS, CS and AS. Okay. So this is the calculation. Now in the code, the decal we are using, so front would be less. And now the mathematics what we are doing, it is same. Only thing is we need to use kind of multi. So instead of text coordinate, we'll use multi-text coordinate. Okay, so GL quad, and here we'll use I think this would be too much to change this much code, it is understood, and here we'll say multi-text coordinate, multi-text coordinate, and here we'll specify both coordinate. So I'll say copy paste because both are same. This is how both we are mapping. Okay, we'll do. Okay, so here and here. So multi-text coordinate because for both images, both textures we have to set. Which texture this is? So we'll specify. So GL texture 0. Texture 0. Texture 0. Texture 0. And here we'll say GL texture 1. TL texture 1. GL texture 1. Okay, I think it's pretty clear now. And image width, I think that is the second image, so it's okay. Image width and image, we can specify hard-bind coordinates also, but it's okay. So now after this we'll close this. Okay, so we are saying GL end and we are disabling the texture. So disabling the texture means whatever the current is that is disabled, that is the texture 1. So that next one also will disable GL active texture GL texture 0, and GL disable. Okay, so first disable the texture 1 because that is active right now. I think we don't need this rotation stuff. So there are two textures, texture 0 and we bind to text name, texture 1 bind to text name 2. So texture 2 it is active now, this is behind and it is replacing whatever is previous and it is doing decal whatever is the previous, it is not replacing. And then here multi-text coordinate 2F, and then if I say disable, then texture 1 is getting disabled, then I say texture active, active texture, GL active texture is 0 and then please disable that also. Okay, so we can try our luck. Python 3 text. '73 GL vertex. Okay, so I'll copy this. I have hut. Okay, I believe hut 2. Okay, so I believe hut size and something is differing. Okay, this is not the hut we want. So I'll try. Okay, we want hut double T. Okay, so we cannot see anything. Means the expectation is hut should be kind of as a ghost image here, the shadow image here. That is certainly not coming. So we'll see what is the problem we have done. Okay, so we have text and text name 2. And here text name 2 is there. We are generating two textures, text and text name 2. Okay, so we are binding texture to text name and we are pushing the image and then we are kind of specifying the other attribute. Same thing we are doing, we are opening hut.png and putting alpha as 50. I'll try more and then we can reduce probably 250 so that it would be 200, it would be more visible. Okay, so transpose the image and text name 2 and then there is no change. Okay, bind texture text name 2 and in display we have set active texture as 0 and text name and replacement and then active texture 1 text name 2 and mode is decal and here we have set the multi-texture coordinate texture 0 and texture 1. Okay, so I think here we have made a mistake, so it should be 1 and it should be 1 and 1. Same thing what we specify 1. Okay, so I think we can try now. So it should not have been 0 0. Oh, far better. So this is multi-texturing. So the hut component is 250, whereas the flower component is only 55. So this is multi-texturing. Now I can change, put alpha. 255 doesn't make any sense. Here, this is the main one as per the calculation. Okay. So whatever is the front alpha, that comes into the picture. So front alpha I'll keep kind of 100. Now, okay, so this is multi-texture. Now I can see that the flower is also there and hut is also there. So the way I'll increase the alpha of the hut will be prominent. If alpha is less, then behind the scene, that is the flower, that will be there, that will be prominent. I can make it bigger. So this is the scenario. Okay, shimmering is there because I removed wave mapping to make it faster. It will go right. I can print the coordinates and I can rotate along x-axis. Okay, no problem, means I can rotate along y-axis. I can move up along the y-axis direction. I can move down. Okay, I can move up in the fixed coordinate, move down. Down. Okay, so I can kind of rotate along the fixed y-axis. I can rotate along the new y-axis. Okay, I can rotate along the global y-axis. You can see global y-axis is rotating. This is the global y-axis. Okay, so we can do kind of a texture transformation, and I can do texture transformation also if we want. I just need to uncomment the code and texture transformation would happen. Okay, so first guy is the target. So first guy would do texture transformation of 20 degree along the z axis, and next one, so flower would rotate. Okay, so flower rotated, where Mr. Hut is same. So this is kind of multi-texture. Okay, so we finished the topics more or less. Okay, now we'll see the specular light component later, and MIP mapping, texture function, multi-texturing, texture object. So we are kind of done. Now the question comes is can we do vertex array? Means it's not possible that the texture coordinate we need to specify again and again. So we need kind of texture vertices should be stored somewhere, and we can kind of do on top of it. So that is the idea. So that we'll see how we can do. So multi-texturing, we'll see. First we'll see the kind of simple way we can do texture coordinate, uh, vertex array. Okay. Okay, so I have vertices that is stored somewhere, so I can just grep on it. Vertices, and okay, so I have vertices. So this is the vertices I already have of a cube. I think four sides of the cube. So I can copy it here. Okay. So this is the first face, second face. I'm sorry. This is the 1, 2, 3, 4. This is the first face. This is the second face. This is the third face, and this is the fourth face. So there are four faces. So cube has 6 faces. I have kind of coordinate of only 4 faces. So rather than typing here again and again, so that doesn't look very good. So that we'll try that 4 face how we can do. So multi-texturing kind of we can just comment it. Or we can keep along, but it will be kind of complex that we are not looking right now. That is not the idea. So only to show the vertex array, that is the idea. Okay, so only one will show, that is the flower one, and here, so only one, text name and GL gen text 1. So only one that we'll see now, and then we'll go to display, and in the display we will add kind of so GL active texture. So these are for multi-texturing. So multi-texturing we'll see in this area also, but right now we'll focus on showing the vertex array. So we'll say we don't need only enable. So by default it will be texture 0, text name and text env. Okay. Now we'll say GL enable client state vertex array, GL enable client state, GL texture coordinate array. Okay, so we have enabled it. Now we will set the vertex pointers. So I'll say GL vertex pointer and 3 GL float. Okay, and GL vertex pointer, the first is the how many vertices are there, so 3. Type is float. Okay, stride, so it is 0, means we will specify the full array now, and in Python we can kind of trim any array. So it is called I believe comprehension. So we'll write a comprehension count x for count x in enumerate, or we don't need x. Okay, so I'll just say for count in range okay, so we have q vertices. So we have q vertices. So q vertices only will iterate. Count in range len q vertices. Okay. Now this is the length. Now if not count %5, so q vertices, it has vertices and texture. So if it is 0 or 5, and if these are the scenario for y in q vertices, count to count plus 3. So this is the vertices. Okay. Now same thing will specify for the texture coordinate. So text chord pointer, but it is only 2, 0, y count in range length of q vertices. If not count 5, but this guy would be 3 to 5. I think it's clear. So q vertices, we have one vertices has 5 thing, 3 are for texture coordinate and 2 are for texture. I mean 3 are for vertices and 2 for texture coordinate. So these are pixels coordinate and these are texel, pixel, texel, pixel, texel. So 5 are there. So okay, so I'll iterate the q vertices. So whatever is length, it's fine to me. And every 5 point, now we'll say count to count 3, that is vertices first 3, and next 2 is texture. Okay, I think I'm done. Now we can just say GL draw array, GL quads. Okay, 0 and int kind of len q vertices divided by 5 because there are 5. Okay, so I think we are done. Now we can disable. So GL disable client state, GL vertex array, GL disable client state, GL texture coordinate array, and we'll disable the GL texture 2D. Okay, so these misters we don't need now. Okay, so all are gone. Okay, so we don't need okay, so all a story we have written it again. So nothing is required, only pop matrix and flush. So everything we have commented. I mean, I believe I can remove these also. So we have commented out everything, not required. So whatever is now I am inside the display, and inside the display I have enabled the texture and bind texture to text name. So it is in texture unit 0 by default, and then GL text environment replace. Okay, vertex array enable, texture coordinate array, vertex pointer, GL text pointer, and draw array. Okay. How many vertices? Length by 5, because every vertices has 5 point, and then we disable it again and disable the texture. We'll try now. Okay, so GL draw array is not defined. So I believe GL draw arrays is the actual code, and function, I think there should be a len and int, so it should be okay. Now we'll try again. Okay, now it should be a queue as per the design. It is a queue. Okay, I can see it is hollow queue, means top and bottom is not there. Okay, otherwise we are drawing the queue. Now it is quite simple, means we can, if we have the vertices in an array, then we have the queue. Okay, this is hollow queue. 4 sides are there. I can force it to far, I can force it to near. Okay, up, down, right, left. Okay, anywhere I can rotate. So this is local axis rotation. If I want, I can show the full axis, and I can rotate along the full axis. So this is GLU perspective we have said. So this is through vertex array. Yes, so nice it is. What is required here is only vertices. If I have the vertices, then the story is over. Only thing I need to put is in the display, okay, only the vertex pointer, and that's it, and just draw it. Okay, so here now we'll have a kind of there is a vertices, big vertices that we can kind of fetch, and we can show that also. If I can show small vertices, then no one can stop me to show the big vertices. Okay, so I have vertices of one aeroplane, the way we are showing here. Okay, so now I'll kind of copy the vertices of aeroplane. So we have these many files. I have copied hut.png, flower.png, aeroplane.obj. Aeroplane.obj, it is generated through Blender, and it has vertices, it has vertex normal, it has texture, and then it has the faces. So these are GL triangles. We can see it is not quad, only triangles are there. So triangles are important in the kind of shaders program we will see. We doesn't take quad. Okay, so we'll modify this code now to have the aeroplane.obj, and Okay, so here in this code, we will copy one file, that object loader. So object loader, it reads the object file and gives us the vertices what we need. So I can say text from object loader. Okay. Import object file. From object loader, import object file. And then we'll start the story. So kind of to be a certain that I don't want this, so I can just comment this. So from object loader, import object file, and in the display, now we'll change this. So enable texture 2D, bind, enable, everything is okay. Here I can say m equal to list. This is the kind of object file, this is how it works. I'll say airplane.object file, please read it and give the objects. Okay, so this is what I want. Okay, so object file, probably this is a class, and we are passing the object name dot objects dot values. Okay, and 0 to 1. So m whatever we get in the m, so we will have vertices in the m, means there is nothing like anything hidden. I can say like from object file, import object file, object loader, import object file. Okay, and m equal to whatever with the code we wrote, object file, okay, it reads it, and we have indices, name, vertices, vertex format, and so many things. Vertex format. So it is a kind of every vertices is 8 in count. First 3 is position, next 3 is normal vector, and next last 2 is the kind of the texture. Okay, other are very big, so I can just type m dot vertices. It is, I think, beyond 1000 or 10,000 or something like that. So this is the code. Now we'll proceed. So vertex pointer is 3, 0, y count lane, so that is m dot vertices. If not 8, because 8 is the stride, and we want first 3, and text coordinate is same, and it would come in the range of m vertices, m dot vertices, and stride is 8, and this meter is 5 to 8. Five to 8 is 3, 6 to 8. Okay, so normal vector I am not normal we are not taking into the account. That's it. Okay. Now len, rather than doing so many computation, I can just say kind of m dot indices. We saw there was one indices, so number of indices. Quad probably will not work. As I showed, the face is triangles, so I can say triangles. 6 to 8, count 0 to 3. That's it. Okay. So Mr. Aeroplane should come. Only thing in display we are calling it again and again aeroplane. So this we can kind of push somewhere else so that it should not read again and again. We can store somewhere. Probably we can do now. So M list object. Okay. Or we can continue. Means this is not the best way to do it. So these are the files Python 3 text, GL triangles, okay, there are errors. Q vertices is not defined, where I am looking for Q vertices. Line number 63, that's why I commented it. Okay, so here it is. So this is the nice thing that we comment what we don't want, so that it should pop up the error. Vertices. M dot vertices, M dot vertices. We'll try again. No error. Oh, certainly there is a aeroplane. Okay, but there is no transformation, nothing. Oh, it's there. Okay. So every time it is, so transformation is kind of, okay, it is slow because every time we are reading from that point. So this is the, okay, so this is the aeroplane. I think I can place it far. I believe it is doing too much computation. So we'll place this M in the init itself. So M equal to, and every time it is kind of doing the computation of the reading. So that is slow. Okay. So in the init itself, I can say M. Okay. And I'll set it M here. And M is also none. M. And now M is available. First time it will read it, and after that M is available. I can set it global here, but if I am reading it, I think it's okay. Means it takes time to type. Okay, so I'll try again. Okay, so Mr. Aeroplane has arrived. I can, so it is quick now, as we expected. I can rotate. So the texture is the flower, and this is how it is written. I can kind of move it up. Okay. So it would go. So this is up. So I believe the next would move it like this. Okay. I can print axis. I can say yeah. So this is the axis. Green color is the y axis, red is x, and Z is not visible. That is kind of in the direction of the plane. Okay, so kind of I can rotate along the Z. Okay, I can make it far so that it would go behind the scene. Okay, and if I say next, it would come, and if I say Z, it will move like this. So this is local coordinate, and I can move up with the kind of grand coordinate, up and down. So okay, so here this is the texture, not that. So we'll see which texture I can copy. So I can say Nemo. Okay, so probably we want 222. Aeroplane.png is there, so I'll copy that. So to delete text aeroplane.png here, and in the text.py I can just substitute airplane flower.png to airplane.png. Okay, so this is set now. Okay, so meta aeroplane is kind of better. Okay, it can really fly. Okay, we can rotate it, I think, along y-axis, and it would come down. It would go up. It would go up. It would go down. Okay, so it would rotate along its own axis. I mean, like this. So we can simulate in this fashion with the texture whatever we want, and we can simulate kind of any fighter jet also. So in the kind of next we'll see shaders. There it will be quicker because we'll use GPU. Okay, we can see the kind of Y. If we press full, it will show. Now if I say near, it would come near us. Okay, we can rotate like this. And it would move. Okay, so kind of we can simulate. So I'll bring it again. Okay, so I'll print the axis, and then we'll kind of so we'll place it far so that it will be little smaller. If I want to see where we are, then I can say kind of as per the global axis. Okay. Okay. So as per the global axis, we are here. Means we are in -z direction. Okay. And so I'll keep like this and let it move. it would rotate. Okay, it would rotate again, and kind of it would move, and it would fly. Okay, so it would rotate and it would come back. Okay, and we believe that it should not make any accident, otherwise it will be like this, like this. If it meets accident, it will fall, otherwise nice. Okay, so see, if I change the kind of, now I have one kind of earth, so I can copy it to delete text. Okay, I have one sphere, so I can copy it as a sphere.object. Okay, I have aeroplane.object. Now I have a sphere.object, and then I have kind of one earth PNG, so I'll copy from, I have one. Okay, so it is Opengl image globe, yes. So I have like yellow map, so I'll say earth, or I can just copy it as it is. Now we'll go to the yellow world map dot text. So I'll go here and aeroplane dot object. So here I'll say yellow, okay, yellow world map, yellow world map dot png, and airplane. So here I'll say sphere.org, that's it. Now it is a sphere.org and texture is yellow world map. Done. Now I'm ready to kind of show it. It's earth. Means this much program I am changing, and now it is kind of earth. I have changed the global axis that I should not have done. So I believe it should be in good shape. Okay, I can scale it. So this is GLU perspective. That's why it is showing near and far and axis in that direction. So probably I'll make it far, and then I can rotate it. Okay, so kind of Africa favorite to everyone. There are lions, so I can zoom Africa. Okay, anywhere we can reach. Like if I say X, then this is North Hemisphere, and if okay, if I say -X, I am coming here. I can go to any country. India. Okay. So pretty clear, means there is nothing here. Okay, so this is little tilted, that what we can see, because our axis is tilted. Okay. Okay, so I can change the texture the way we want. So we have okay, so image globe, we have other textures also. So I can place like a satellite image. So I can copy image globe, satellite, okay, here, and in the texture yellow stuff, I can just say satellite 5000 2500.jpg. Okay, we'll try our luck. Satellite satellite 52. Okay, this is the image. Python 3 text. That's it. I just modified the code to have another texture, another earth. Okay, and so beautiful. I can scale, and then I can kind of see. Okay, so I have Africa. Okay, it is little tilted, so we can correct it. I'll try Z. I think this is the correction. Nice. Okay, it is tilted because we are using GLU perspective. In ortho, there would not be any problem. Okay, I think we can try. Means there is no stopping. So we'll use GL ortho and so GLU perspective. So we'll comment this, and we'll have GL ortho, and that is minus 2.5, 2.5 minus 2.5 into. Okay, so we'll go for width greater than height, or we'll type complete thing. Okay, into HY width 2.5 into HY width 120. Okay, 1 up to 20. If width is less than equal to height, else GL ortho minus 2.5 into width by height 2.5 into width by height minus 2.5, 2.5, 1 and 20. Okay, so I think we have done some nonsense. GL ortho one. We'll keep up to 30 so that we can kind of scale little nicely. So minus 2.5, 2.5 HYW, 2.5, 1 to 30, minus 2.5 width by height, minus. Okay, so we are done. Now GL translate. So we'll keep up at 8 so that we can kind of rotate. Okay, so we'll try now. Okay, so this mister should not do anything wrong now. Okay, so there is no deviation. Okay, so along x-axis I am rotating. I can bring back to original position, and this is along z-axis. I think one is tilted along x-axis. Okay, one is along z-axis, it is 370, other it is y, it is fine. So z-axis will, okay, so now we can kind of rotate along z-axis. Okay, so this is the axis, current axis. It is little bit tilted, so that's why it is showing the tilt. Actually, we are kind of making 10 increment, so it is not coming the way what we are thinking. Okay, so we can scale. And we can rotate. Okay, so India is like this now. So India is like this, the way we want. We can zoom. Okay. If I zoom more, then it is coming out of the projection box. So up to here only we can zoom. Okay, so I can say, okay, going far and coming near, it doesn't make any change in the GL ortho. Okay, I can see Antarctica if you want. So now next we'll see the kind of okay, so we can place whatever map we want, and this is the Earth. Okay, so next, so we saw this, and next we'll see the secondary or specular color and multi-texturing in the vertex array. So vertex array also multi-texturing is possible. So that we'll see, and that's it. So a specular lighting and then multi-texturing in the vertex coordinate, that we'll see. Okay, so we'll add the lighting. Now I will enable the lighting. Okay, so where we can add, we'll add it here. So we are inside the init function, and we'll enable the lighting here. GL enable GL lighting, GL enable GL light. So only one light source will enable. GL will enable normalize also, and this one, the what we are talking, this one, GL light model. So this one will kind of add GL light model I, GL light model color control separate specular GL light model I, GL light model, color control, GL separate, specular color. That's it. We are done. Now we'll just add the position of the light. So position of the light we can add here. Now GL light FV. So we'll add one vector. So GL light 0, GL position, and we can specify kind of 2 in Z direction, and it is positional light, and GL light FV, GL light 0, and GL specular, and we'll set a specular like this. Now we have to enable the vertex normal vector, otherwise shining will means lighting will not work. So we'll enable normal vector and we'll disable normal vector. Okay, normal vector as we have already seen, so this won't be there, and so instead of vertex pointer it is normal pointer, and it is from 3 to 6. Okay, that's it. So we have a normal array enabled, disabled, enabled, and normal pointer. Now we'll add material. So GL material FV, GL front, GL specular, kind of 4. So 4, 4, 4, and 1. Done. So material we have set. We'll set shininess also. It should shine. Shininess kind of 20. Specular we have set. Normal vector we have set. Okay. So in the local axis we have set the position before the transformation, so that it should not rotate. Light source is fixed. And 1.0, so this is positional light and enable. Okay, so we can try. Oh, so lighting is there. I mean it is visible. Okay. GLU perspective will enable the perspective. Okay, and GL translate will make it near so that it would appear bigger at the beginning only. Okay, so the light source is 2 units away in the Z direction. So if I bring it near, light would go away. Going away, only few pixels are there. And it went away because it is kind of it crossed the light source, and light source is far. Okay, I can rotate. So this is shining. So this is kind of in texturing. The secondary color, the specular color is kind of calculated post texturing. Once texturing is done, then a specular color is added. So nice. I can scale. Okay, it went beyond the beyond the light source, but whatsoever. Okay, we'll set position. So we'll use a kind of directional light. Now it will be better. Okay, whatever we do, the light will not go away. It may cross the projection matrix itself, but that's it is crossing. But light source will not go away. Okay, so this is specular. Okay, this is India. Okay, it is crossing the projection matrix. Okay, so this is how it is. Okay, so it is flat. Okay, I think now it is more visible, the shining. Okay, so shining would be kind of in any texture, so will change. So wherever we see yellow world map dot png, substitute that with satellite. Oh, so shining is here again. So no problem. We can bring the axis. So this is the axis. This is grand axis and local axis. So we are rotating along the local axis. Local axis is also getting rotated. Okay, so now along y axis it is rotating, along z it is rotating, along x it is rotating. Okay, through grand coordinate also we can rotate. So fixed y it will rotate. So we can bring it to some shape, whatever we want, in this fashion. Okay, it will not come the way we want because we have it. It is not very fine. It is 10 degree. It is calculating. So in that fashion, it may not come to the origin what we are thinking. But still, this much we can get. Okay, so we can rotate across global axis also. Okay, so this is lighting. Now we can have multi-texturing in the lighting itself. I think it will be too big if I write code for multi-texturing. So I can open the kind of Opengl utility code and I can show the multi-texturing. Okay, so in multi-texturing, we are kind of using one more guy, that is client active texture. Okay, so client active texture, client active texture, their material, and then we enable 2D and then we bind texture, and then one by one we enable it. I think we can do it. Then we'll use this It will be quite complex. We'll try. Okay, so multi-texturing, so we'll here we had done this kind of stuff, so we'll leave it. Image dot close, and there is another image, so will remain as hut.png and alpha. Okay, so we are enabling multi-texturing here also, and now it would be kind of instead of 1 2, so generate texture 2 and first one and second one. Now in the display code will be for multi-texture, it will be complex. Okay, so we'll do the complex. Okay, so what is in multi-texturing? GL active texture 0 and then GL client active texture. So we are doing multi-texturing in vertex array, and this is kind of precious. Okay, and then we'll have, this is what is in the OpenGL code. Okay, so then material, then all this stuff, and then vertex normal and texture. Okay, so material stuff will shift after the here. Then we enable texture 2D, bind texture text. Now we enable vertex array and we'll push it here. We enable normal array, we'll push it here. We enable texture array, and then we'll draw, and then we'll disable all three one by one. Okay, and we'll disable texture 2D. Okay, so before draw, now in multi-texturing the other guy will come. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now again we have to do for texture 1 the same stuff. Okay, this is texture 1, and again same stuff, 2 and mode and replace. So instead of replace, it would be decal and vertex array and same thing. Okay, so vertex pointer are same, but image is different. That's it. Now we will happily draw, and then we'll disable. Okay, now we will kind of now, so we don't want texture transformation. Okay, so this also we don't want. So we'll activate GL texture 1. Texture 1 is already disabled, so 0. Okay, so this is not I am looking. Probably will remain it as inactive. I am trying to disable the texture 2. Here it is the code. Okay, so we'll disable texture 2. So active texture 0. Okay, so client active texture. Now we'll disable these three YY. Okay, so since for each texture unit, now when we go for multi-texture, whatever we are doing, we have to do for each texture unit. That is the concept. So real texture 1, 1 and 2 and decal, and then same story. Okay. Draw the array. I believe it should be separate. So disable 3 and disable texture and active texture 0, client active texture 0. Okay, so we will try. Oh, something is there. So I'm expecting hut. It is there. So this is multi-texturing, means earth and kind of hut. So both are coming. Okay. So this is, and a specular is also there. There is a shining and hut. So I think I have one copyright image. I think that I can copy text, copyright image. Okay, so instead of hut, I'll say copyright PNG, and the alpha will make it small, kind of 40, so that it should come in minimum fashion. We'll try again. Okay, so now our kind of this fashion is copyright. Now copyright and the earth both are kind of blended. So this is multi-texturing and vertex array. Okay, shining is also there. Okay, we can rotate, we can scale the way we want. Shining remains. We can print the axis. I think it is okay. Local axis. Okay, now local axis is visible. Along the local axis I can rotate. So this is perspective. Now I can, along x-axis I can rotate like this. I can bring to the original shape. Okay. Okay, so this is multi-texturing, lighting. So we have finished all the topics what we kind of had. Okay, so map, specular light, texture function, multi-texturing, texture object, and designing. Okay, so we have one shape class. So kind of through that we can have, like what we are doing now is in the code. If you see, then we have only one. We have only one sphere.obj, and that we can replace. We can have many. I mean, countless images. We can kind of try here. So for that we will kind of will mask everything, all the story whatever we have done. Okay, except lighting. Okay, so and here we'll have kind of different shapes that will come into the picture. So I can say airplane equal to shape, ob equal to, so okay, so what is this ob? So here it is sphere dot airplane dot ob, okay, and then followed by what is the texture. So texture we can, so this is ready-made library that we have written, so that I am showing kind of yellow map, yellow world map.png. Okay, if there are other things that we need to mix it, so I'll say copyright.png, and 40 is its alpha, and specular, so this much code what we have written on the top we need not write, so 4 0.4 and 0.41, and shininess equal to 20. Okay, so this is Mr. Aeroplane, and I think we wrote about the earth, so aeroplane will keep it simple. So this is, I think, earth, and it is sphere, okay, and then yellow, so this looks even better, and in aeroplane we will have aeroplane.ob, and texture we will have kind of airplane.png, and copyright and everything will leave. So now we have aeroplane and earth, two things are here. So in the global we'll have kind of airplane and earth. Okay, so we'll kind of comment this all together so that it should give error if we are doing nonsense anywhere, and we'll have airplane equal to earth equal to none. Now we have imported from the Opengl util, shape is the class, util C is there. Okay, so we don't want this text name and text name too, only airplane is there. Okay, all these codes are gone, only two line of code. Airplane, what is the airplane? Ob equal to, texture equal to, that's it. Now in display we are going to use, okay, so this much fashion we don't need now, GL active texture and so many things, so we'll mask it completely. Okay, only pop matrix is there, otherwise we have commented everything from here to here, so only this much code is remaining, that is at the top, GL push matrix and GL transformation axis. Now here we'll iterate, okay, so I'll say for L shape in shapes, okay, and shapes must not have a global, so I can say kind of L shape for L shape in shapes, if L shape not equal to global, because global we don't want, and here in L shape we'll add, so right now I have image, so I'll say airplane and I'll say Earth. Now we have global airplane Earth in the shapes, and every time I come here, so first is the kind of drawing the global transformation matrix. Next time we are iterating for L shape in shapes if L shape is not equal to global, and then we are pushing the matrix light V and then transformation. So instead of image it would be L shape. Okay. GL pop matrix. Okay, so if L shape equal to airplane dot show, if L shape equal to earth dot show. Okay, so only this much. I believe the function is display. Okay, we just need to display, and transformation anyway we are doing, lighting we are doing, push and pop. Now down the line, so only one pop is required. One pop will comment. That's it. So this way we can have so that client library, library, it takes care of everything, and then we can draw. Let's try. Okay, so it is giving error. Okay, no yellow world map, it's there. Yellow world map. Sphere is not there. Sphere dot opt. Okay, still there is a problem. Key error L shape. So L shape is variable, it's not constant. So 66 L shape. Okay, so whatever in shapes we are iterating, and if it is not global, then we are pushing to the matrix, and okay, then light calculation, transformation for that shape. Okay, so we'll try again. Python 3 text. Oh, now we have kind of okay, so I can press V and I can see the selected shape is airplane. So only airplane would move. So I can say kind of for, and I can rotate along y-axis. So this is kind of multi-texturing, or we can use multiple objects we can use. Okay, now aeroplane can move separately. Okay, So aeroplane can fly. Now if I press tab, then I'll move to next shape. So that is Earth. Now Earth can rotate. Earth can go left. Okay. Now if I press 2 tabs, then I'll come to aeroplane, and then we have our own fundamentals of the aeroplane. Okay. I'll move it little right, the Earth. Earth would rotate, no one can stop it. I can print axes. So everyone is in own axis, we can see. Earth is it has own local axis, and plane, it has own local axis. Now where I am, so I have pressed V, so I have selected Earth. Now I can press 2 tab and I come to aeroplane, and then aeroplane would fly. Okay. So now we can see that multi-texturing has taken place. Copyright is at both places. Okay, so we can rotate the plane to come down. Okay, it can pierce the Earth. Where we are in the global axis, that we can see. I'm sorry. So global axis we can rotate. So Earth and plane, plane cannot pierce the Earth because it is in minus z direction. It is a little away. So I can rotate the plane. Okay, and I can see the global axis where they are. I believe now it can pierce. Okay, it should pierce. Okay, it's still it is little away. Okay, so I think we have done a lot. We are in aeroplane, so I can move right aeroplane. Okay, so global axis we have rotated. Okay, so that is the scenario. So we can have multi texture also. So I'll show the code again. And this is how we get the multi-texture. So now it is piercing because both are at center, and so we have to come to this stage. Okay, so we are at aeroplane, and we can make it far so that it will be small. Okay. So aeroplane can rotate around the Earth and whatever we want. So we'll get the Earth left. Okay. Now aeroplane is moving. It can move. It can come down. So this is the scenario. It can rotate along one axis like a fighter jet, or I can make it appear like it is coming near us. We can okay, so it would come like near to us. Lighting is enabled, so we can clearly see the signing. Okay, just we can change the texture and we can have whatever we want. Okay, so this is about texturing. I believe I can bring another window so that I can show the code on top of it. Okay, so full story is at the end we have used a library that is inside OpenGL util, shape and util C. Otherwise, this is the code in init. We did multi-texturing, we did lighting, we have lighting. Now instead of multi-texturing we are using library functions like shape, and whatever multi-texturing we are writing this big code that we have to just pass through arguments, and in display we just need to iterate and then we just need to say display. So I think rather than this much I can just say lShape.display. This is also enough. Whatever the shape it is iterating, so just that is also enough. So whatever else shape it is getting, it is just a display. And these are the story of multi-texturing, that and then rotation, texture transformation, and so many things we have done. We have keyboard, and this is the util keyboard we call because it does the calculation of the transformation matrix and reshape, and that's it. Okay, and then we have so nice, we can so we can simulate kind of the real scenario graphics. Plane can go up, plane can come down, plane can rotate on its own. I can print A, so these are the axes. So plane can rotate like this, plane can move in its own direction. Pretty clear. Now it's a fighter jet. It can go back. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.